welcome to my channel. So in this video there are two goals. The first goal is to see how to solve this problem, then we are going to do some coding work, and the second goal is to see how we should behave in a real interview. So let's get started. So remember, in the real interview, the first step is always try to understand the question. If there's anything unclear, please bring out the question to the interviewer, and at the same time think about some edge cases. So let's take a look at this question. So given the root of the binary tree, determine if it is a complete binary tree. So in a complete binary tree, every level except possibly the last is completely filled, and all nodes in the last level are as far left as possible. So you can have between 1 and 2 to the power of each node inclusive at the last level. Okay, so let's see the first one. This one is going to return true, so the condition to see if it is a complete binary tree is it doesn't mean that it's a full tree. It means that for the last layer it could be like as left as possible. That's fine. But this one, it is going to return false because the node 7, it is not as left as possible. Alright, so let's see the constraints. It says that the number of the nodes in the tree is in the range of 1 to 100, and the node value is between 1 to 1000. Okay, so that seems to be pretty clear to me. So the next part, what we should do is we should try to find a solution. So how to solve this problem? Let's see. I would say we could use BFS to solve this problem, and so how to use BFS to solve this problem? So during the time we do BFS, so you know that for a binary tree, suppose that we have the root node as 1, and then what we learn in the class is that we could have like the second layer, like we could give each of the node a ID, so the node ID. So the root is given 1, and for the second layer it is 2 and 3. Third layer for 2, 3. For third layer 4, 5, 6, and 7, and so on and so forth. So essentially, suppose the ID of the corresponding node is I, then the left child node is going to be 2 times I, and the right node is going to be 2 times I plus 1. So that will be the ID assignment for each of the node. Suppose finally the size of the tree, the number of the nodes, match the last ID, which is the maximum ID. Then what we could say that it is a full tree. Otherwise, it is not a full tree. So for example, like this one, the last index is 7, but there are only 6 nodes in the tree. So having said that, the runtime is going to be like all of n, and space-wise it is going to be all of n as well. So n is the number of the nodes within the tree. So that's a BFS solution, and then let's do some coding work. So for coding, take care about the correctness of the code, the readability of the code, and also don't be too slow. So let's get started and do some coding work. So it says that it is not going to be empty, so we don't need to check that. So we can directly start the logic for BFS. So for BFS, remember the most important part is the queue stuff. So first of all, we have a queue, which is let's say I define another one. Let's say it is the node class node. So it will have the tree node. That's the node, and also let me also have the ID. So class public node. So let's give it a constructor. So this one is tree node, and this is ID is node, and this ID is equal to ID. All right. So we have the node Q is new, and add the root into the queue. Yeah, so let's say the number of the nodes. So we need to keep track of the number of the nodes we have visited, and also the last index. So let's say this is num node is equal to 0, and then the last IDX is equal to 0. So okay, so this one should be new node, the root, and also we give the root as index as 1. So this as well, the queue is not equal to, is not something empty, then we are going to have size as equal to queue dot size. So for within the for loop, so this one, it is just saying how many of the nodes are there within the queue. So this is to tell the layer of the size, but in case you don't want to do that, that's also fine. But that's just my way to use to write BFS. And then within this layer, it has I nodes. So we are going to first pop the node from the queue. The plus the num nodes. And also we are going to say the index. Okay, so the last IDX is equal to node dot ID. Okay. And then if the node is not equal to none, then what we are going to do is we are going to queue dot add the new node, the node dot left, and the node dot ID times 2. If node dot right is not equal to none, then we are going to add the node as well. So node dot right and node ID plus times 2 plus 1. Alright, so finally we just need to return num node is equal to last IDX. Alright, so that's pretty much it. So remember, after you're done with coding, please do some testing. So for this platform, I would just rely on this system to help us to do the debugging work. So cannot find symbol q dot is empty, right? Node dot it is node dot left, node dot right, node dot ID outcome. Okay, so let's do a submission for it. Alright, so it seems like everything works well. So that's it for this coding question. If you have any question, feel free to leave some comments below. If you like this video, please also help subscribe this channel. I'll see you next time. Thanks for watching.